Work is generally managed positive growth is the displacement is the displacement is the fraction of force that is W and 1/2 FT. This is very useful relationship between because it enables us to find working. Very relation because it enables us to find what required to rise way to or to move a charge particle through a magnetic field. However, when treating thermodynamics from a microscopic point of view, it is advantageous to link the definition of work with the concept of system properties and processes. We therefore define work as follow. Work is done by a system if the sole effect on the surrounding everything external to the system will be the rise avoid notice the rising of what is in effect of force acting through a distance. Notice also that our definition does not state that a weight has actually rise or that a force actually acted through a given distance acted through a given distance, but only that the sole effect external to the system could be mm, could be the rising of weight. Work done by a system is considered positive and work done on system is considered negative. Negative the symbol WW and designate the work done by a system. In general, work is a form of energy in transit, that is energy being transferred across a system boundary. The concept of energy and energy storage are possession was discussed in detail in section 2. Work is a form of energy that fulfills the definition given illustrated definition of work with a few examples. Consider as a system battery and motor. Consider a system battery and motor. And let the motor drive a fan. Does work across the boundary of the system to answer this question using the definition of work given. Uh, Replace what is rising and the soul external to the system is the rising of weight. Thus for our original system, we conclude that work is crossing the boundary of the boundary system since soul effect external to the system could be the rising of weight. Let the boundary of system be changed now to include only the battery. Across the boundary of the system to answer the question we need to ask a more general question. Does the flow of electric energy across the boundary system constitute what the only limiting factor or when the solar effect is rising of weight is bearing and bearing we recognize that we can approach the certain limits that meet the requirement of having the only external effect of the effect be the rising of a weight. Therefore we can conclude that when there is a flow of electricity across the boundary of a system. Example of work crossing the boundary of a system because of electric current flow across the system boundary. Mm. There's already noted by the system sources that don't by against the piston. Is positive and work done on the system sources that and done by a piston completely as negative. The positive work means the energy leave the system, and negative work means the energy related to the system. Amortization of work involves rising of weight, that is the product of a unit force acting through a unit distance. And the unit of work is just a unit. Power is the time rate of doing work and is designated by the symbol W. 1 Newton meter is equal to transfer of energy without transfer of mass, because the temperature difference between the system and the surrounding is called heat transfer. Transfer of energy without mass, because the temperature difference between the system and the surrounding is called heat transfer. Heat gain by the system is always positive. Heat gain by the system by gain by the system is always positive. Is rejected by the system is negative. Work transfer. The work is done by a force as it acts upon a body moving on a direction. Work done is equal to force into displacement. Work done is equal to force into displacement. The work is done by a force. The work is done by a force as it acts upon a body moving in a direction force. The work is done by a force as it acts upon a body moving on a direction force. Work done is equal to force. W is equal to 1/2 Work done by the system is positive. Work done on the system is negative. By the system by the system by work done by the system is positive. Work done on the system is negative. Work done on the system is negative. Work done by the system is positive on the system. On the system is negative, bottom by the system is positive, on the system is negative. सिस्टमले गरेको कामलाई चाहिँ पोजिटिभ भन्छ भने सिस्टममा गरिने काम चाहिँ नेगेटिभ भएर गएर सिस्टममा गरिने नेगेटिभ work is said to be done by the system if the sole effect on things external to the system can be reduced to the rising of work is said to be done by the system by the system if the sole effect on things external to the system can be reduced to the the Odin is given by the area under the area under one the question in figure two. Since P is an all time dynamic coordinate all the states and pass through by the system as the volume changes as from volume changes from B1 to B2 must be equilibrium condition must be a condition the piston moves infinitely slowly so every step pass through its equilibrium state the integration of the integration of PDB can be performed only on a quasi static path. The material since P is an harmonic coordinate. The piston moving finally slowly. So every step pass through it equilibrium steady. The integration can be performed on the static path function and point function. One to property locate a point on the graph. Then those properties are called point function. One to properties locate a point on the graph. One to properties locate a point on the graph. Then those properties are called point function. And those other properties whose value depend upon the path taken by the system. Work can only be done when the system goes from one state to another state. About in various static pressure is very W is equal to PdV W and the heat will be pressure constant. constant temperature process PC pressure pressure volume relationship or P1 is equal to PT is equal to PV P1 is equal to PT P is equal to W is equal to W is equal to P log BT by BN BT log BT by B1 equal to C1 there is an isothermal new temperature isothermal isobaric isotonic C1 isotonic volume constant volume constant isothermal temperature constant temperature constant and the volume and relationship for ideal gas and zero is undergoing a steady and constant temperature process is given if PB is equal to C. Pressure volume relationship in ideal gas under constant temperature process is given by pressure volume relationship or ideal gas undergoing a constant temperature process is given by PV is equal to CPV. P1 V1 is equal to P2 B2 is equal to PV of PV just P is equal to P1 V1 by P1 V1 by P is equal to P1 V1 by PdB is equal to work done is equal to PdV by W is equal to P1 V1 by V into dV by त्यसपछि W is equal to P1 V1 integration dV by V अब यसलाई चाहिँ कतै P1 V1 V2 by V1 P1 V1 log V2 by V1 यो भनेको के भयो त आइसोथर्मल टेम्परेचर कन्स्टेन्ट भएको You can and this person really difficult to thermal value temperature constant natural variable volume constant and polytropic process PV kappa n is equal to C n is equal to polytropic index यताको चिज यताको चिज यतादेखि रहेछ यार त्यही भएर हो क्या हो यस्तो गर्दाखेरि बल्ल ठ्याक्क अक्षरहरू सिधा हुने कागज ह्याप्पीडेन्ट बल्ल सिधा हो नत्र क्यामेरामा उल्टो देखिन्छ गुड 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 तयारी नझुक्किने आफ्नो घाँटीमा यता मैले यतातिर फर्काइरहेको खास उता फर्केर टाउको सिधा गराउनलाई कन्फ्युज गराउँछ यार आफ्नो भन्दैछ हुन्छ यता बल्ल 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 सिस्टम भन्दै अब आउँछ हाम्रो पोलिट्रोपिक प्रोसेस भनेको चाहिँ के पोलिट्रोपिक भनेको चाहिँ के हो पोलिट्रोपिक प्रोसेस भनेको पिभीको पावर n इज इक्वल टु c झाडु भयो नि यहाँ मलाई दुख्छ प्रोसेस कन्स्टेन्ट भनेको आइसोभेरिक भयो पिभी इजिकल टु सी भनेको आइसोथर्मल भयो आइसोथर्मल भयो पिभी गामा इजिकल टु सी भनेको यो एडिएबिएटिआइसी भयो भी इजिकल टु भोल्युम कन्स्टेन्ट भनेको चाहिँ आइएसओ सिएचआरआइसी आइसोचोरिक भयो पिभी गामा भने एडियाबेटिक process thermodynamic process which occur without transferring heat or mass between the system and surrounding case constant here P1 V1 को power P1 V1 को power n is equal to PT VT को power n is equal to PVN polytropic process P1 V1 को power n is equal to P1 V1 को power n में VN by W is equal to PdV by PdV and where P को ठाउँमा P1 V1 by P1 V1 को power n by VN by dV भयो and W is equal to P1 V1 को power n P1 W is equal to P1 V1 को power n B के पावर माइनस n dV B के पावर माइनस n B के पावर माइनस n dV B के पावर माइनस 1 dV B के पावर माइनस 1 dV W is equal to P1 V1 n P1 V1 n W v to power minus n plus 1 minus n plus 1 minus n plus BT derivative process PV gamma is equal to PV gamma is equal to C. Both are path function and IN inexact differentiation path function and inexact differentiation both are path function and inexact differentiation both are boundary phenomena PH and phenomena both are boundary phenomenon both are associated with a process not a state both are associated with a process not a state both are associated with a process not a state system possess energy but not work or aid system possess energy system possess energy but not work or aid system possess energy but not work or heat. Both are path function and inexact differentiation path function and inexact differentiation both are path function and inexact differentiation both are boundary phenomena. Both are boundary phenomenon. Both are boundary phenomenon. Both are path function and inexact differentiation. Both are path function and inexact differentiation. Both are associated with process not a state. Both are associated with a process not a state. Both are associated with a process. Both are associated with a process. Both are associated with a process not a state. System possess energy but not work or heat. Differences on in heat transfer temperature difference is required but not in work transfer heat transfer temperature difference is required on work transfer in a stable system in a stable system there cannot be work transfer in a stable system there cannot be work transfer. However there is no restriction for transfer of heat transfer in a stable system एउटा stable system मा चाहिँ के छ work transfer cannot stable system there cannot be work transfer. However, there is no restriction for the transfer of heat. In a stable system, there cannot be work transfer. In a stable system, there cannot be work transfer. However, there is no restriction for transfer of heat. The solid S0 to the system could be reduced to size of the weight but in case of heat transfer the other effect are also observed. The sole effect S0 to the system could be reduced. The sole effect S0 to the system could be reduced to rise of weight. But in case of heat transfer other effect are also observed. The sole effect S0 to the system could be the sole effect to the system could be reduced to rise of weight reduced to rise of the sole effect S0 to the system the sole effect S0 to the system could be reduced. The sole effect S0 to the system could be reduced. The sole effect S0 to the system could be reduced to rise of weight but in case of heat transfer other effect are also observed. Pure sustain, pure sustain. A pure sustain is a system which is homogeneous in composition, homogeneous in chemical aggregation, homogeneous in composition, invariable in chemical. Aggregation, homogeneous in chemical aggregation, homogeneous in chemical aggregation, invariable in chemical aggregation, invariable in chemical aggregation. Pure substance is a system which is a pure substance is a system which is homogeneous in composition, homogeneous in chemical aggregation, homogeneous in composition, homogeneous in chemical aggregation, homogeneous in chemical aggregation, invariable in chemical aggregation, Mm. Homogeneous in composition, it means that the composition of each part of the system is same as the composition of every other part. It means that the composition of each part of the system is same. It means that the composition of each part of the system, is same as the composition of every other part. It means that the composition. It means that the composition of each part of the system is same as the composition of every other part. Figure 1 is steam water. Figure 2 reacts 2 plus 1 by 2 O2 1 by 2 O3 reacts 2 plus element must be combined chemically in the same way in all part of the system. It means that the chemical element must be combined in chemically. It means that the chemical element element is the it means that the chemical element must be chemical element must be combined chemically in the same way in all part of the system. आफ्नो लाइभ कस्तो देखिने रहेछ त आखिर कस्तो देखिन्छ त लाइभ हेर्नु पर्यो गणेश पोखरेल पोखरा गुड मर्निङ हो डिले हुँदो रहेछ यार त्यहाँ मान्छे किन एउटा कति ढिलो देखाउँदो रहेछ के हुनेछ फेरि लाएर यो मेरो दाहिने हात हो यतापट्टि छ बिस्तारातिर है बिस्तारा त त्यही त देखाउनु मात्रै त क्वालिटी चाहिँ Homogeneous in composition भनेको के हो त भन्दा it means that the composition of each part of the system is same as the composition of every other part. एउटा composition of एउटा पार्ट चाहिँ अर्को पार्ट जस्तै सेम नै हो के. It means that the composition of each part of the system is same as the composition of every other part. It means that the composition of each part of the system. It means that the composition of the composition of each part of the system is same as that the composition of every other part. And homogeneous in chemical aggregation homogeneous भनेको चाहिँ it means that the chemical element must be combined chemically in the same way in all part of the system. It means that the chemical element must be combined chemically. Chemical element must be combined chemically. It means that the chemical element must be combined chemically in the same way in all part of the system. Chemical element must be combined chemically in all part of the system. And very invariable in chemical aggregation. It means that the state of chemical composition of the system does not change with time. Mm, but if the temperature remains constant, the volume of a system, the volume of a given gas is inversely proportional to one by T one by T two. चार्ज दिएका छन् के हो यो JYS LUS ग्लास लाइन. If a pressure is held constant, the volume of a given mass of gas varies directly as the absolute temperature. If a pressure is held constant, the volume of a given mass of a gas varies directly as the absolute temperature. If the volume is held constant, the pressure of a given mass of gas must vary directly with the absolute temperature. If the volume is held constant, the pressure is of a given mass of a pressure of a given mass of gas. The pressure of a given mass of a gas varies directly with the absolute temperature. If the volume is held constant, the pressure of a given mass of a gas. If the volume is held constant, the pressure of a given mass. If the volume is held constant, the pressure of a given mass of gas varies directly with the absolute temperature. Direct probability. Pressure constant. Specific volume of condition will be the volume of given gas Page number 43. Islam. The temperature remains constant. The temperature remains constant even in volume. Gas volume of given gas volume of given gas is inversely proportional to P if the temperature remains constant, the volume of given gas. If the temperature remains constant, the volume of given gas is inversely proportional to if the temperature remains constant, the volume of given gas is inversely proportional to Pani. If a pressure is L constant, if a pressure is L constant, L constant, the volume of given mass of gas. Gas, whereas directly as absolute temperature directly as the absolute temperature. If the pressure if the यदि pressure चाहिँ constant राखियो भने the volume of given volume of given and GAS gas VARIS value DIRECT directly is the AB UTE temperature. Constant pressures and constant air pressures. साला if the pressure is at constant the pressure constant राख्यो भने the volume of given mass of a gas. If the pressure is at constant, if the pressure is at constant, the volume of a given mass of a gas varies directly as the absolute temperature. If the pressure is at constant, the volume of a given mass of a gas varies directly as the absolute temperature. Absolute temperature is directly proportional to T. If a pressure is held constant, the volume of a given mass of a gas. If a pressure is held constant, and constant, the volume of a given mass of a gas. If a pressure is held constant, the volume of a given mass of a gas varies directly as the absolute temperature. If a pressure is held constant, the volume of a given mass of a gas varies. If a pressure is held constant, and constant, the if a pressure is held constant, the volume of a given mass of gas. If a pressure is held constant, the volume of a given mass of a gas varies directly. The absolute temperature function is directly proportional. P is directly proportional to T. If a pressure is held constant, then the volume of a gas varies directly with the absolute temperature. And this was if the volume is held constant, if the VO यानी volume is यानी held CO यानी STA and T constant, and then the pressure of a GIV and given mass of gas, pressure of a given mass of a gas VARIS, whereas DIRECT directly with the ABS, so absolute temperature P is directly proportional to TV. Mm, 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 यदि वॉल्यूम कांस्टेंट रहे यदि टेम्परेचर if the temperature constant रहे अनि यदि temperature constant रहे अनि temperature constant रहे अनि चाहिँ यदि temperature constant रहे अनि volume of gas is inversely proportional to the pressure inversely proportional to the pressure. अनि यदि चाहिँ pressure लाई constant राख्यो अनि चाहिँ pressure लाई constant राख्यो अनि pressure लाई constant राख्यो भने चाहिँ volume चाहिँ directly proportional to temperature, proportional to temperature. अनि यदि volume लाई constant राख्यौं भने pressure चाहिँ directly proportional to temperature. Equation of state. अंडा बसालेको छु guys, अंडा खा लो pressure constant भयो, यो temperature constant भयो, 1 देखि 2 भयो, T1 A 2 अनि and here V1 by A1 is equal to T1 by T1 by volume 1 by volume A is equal to temperature A by temperature 1 by temperature A, and V1 is equal to T1 by TA by T1 by T1 V1, and VA is equal to T2 by T1 V1, and T2 by T1 V1. प्रोसेस एकदेखि एसम्म गर्दाखेरि भोल्युम 1 देखि भोल्युम एसम्म टेम्परेचर त्यसमा प्रेसर कन्स्टेन्ट हो। क्या गैस यो नबुझेको के भन्दा V1 भोल्युम 1 देखि भोल्युम 1 लाई भोल्युम ए हेलिकप्टर आयो प्योर सब्सटेन्सको फेज चेन्ज कसरी भन्दाखेरि त्यो पिस्टन भयो त्यो लिक्विड वाटर भयो त्यो वाटर भ्यापर भयो त्यो लिक्विड वाटर भयो त्यो वाटर भ्यापर भयो होइन फेज चेन्ज अफ वाटर एट constant pressure from liquid to vapor consideration 1 kg of liquid water at 20 degree Celsius and atmospheric pressure at 20 degree Celsius 20 degree Celsius 1 kg of liquid water 1 kg of liquid water at 20 degree Celsius and atmospheric pressure and during the process of heating the volume slightly increases during the process of heating the volume slightly increases process of हिटिङको बेलामा चाहिँ के हुन्छ भन्दाखेरि हिटिङको बेलामा भोल्युम चाहिँ स्लाइटली इन्क्रिज हुन्छ slightly increase हुन्छ if the heating of liquid after it at an temperature of 100 degrees Celsius is continue it undergoes a change of phase के हुन्छ भन्दाखेरि ड्युरिङ द हिटिङको प्रोसेसमा चाहिँ भोल्युम स्लाइटली इन्क्रिज हुन्छ यदि चाहिँ त्यो हिटिङ अफ लिक्विड यदि चाहिँ त्यो लिक्विडले 100 डिग्री सेल्सियस एटेन गरिसकेपछि पनि कन्टिन्यू हिटिङ भयो भने चाहिँ त्यसले चाहिँ के गर्छ भन्दा फेज चेन्ज गर्छ And the amount of heat required to convert the liquid water completely into water completely into vapor under this condition is called the heat. Mm, the amount of heat required to convert the liquid water completely into vapor under this condition is called the heat of vaporization. यदि त्यो वाटरलाई चाहिँ लिक्विड वाटरलाई चाहिँ जति हिट त्यो लिक्विड वाटरलाई चाहिँ कम्प्लिटली भ्यापरमा चेन्ज गर्नको लागि जति हिट रिक्वायर हुन्छ नि त्यसलाई चाहिँ हिट अफ भेपराइजेसन भन्दो रहेछ The temperature at which vaporization take place is at a given pressure is called saturation. The temperature at which जुन टेम्परेचरमा चाहिँ भ्यापराइजेसन हुन्छ नि भ्यापराइजेसन हुन्छ गिभन प्रेसरमा त्यसलाई चाहिँ के भन्छ भन्दा स्याचुरेसन टेम्परेचर भन्दो रहेछ। स्याचुरेसन टेम्परेचर एन्ड द गिभन प्रेसर इज कल्ड स्याचुरेसन प्रेसर। प्रेसरलाई चाहिँ दिइरहेको प्रेसरलाई चाहिँ सेचुरेसन प्रेसर, अनि फेरि दिइरहेको उसलाई चाहिँ टेम्परेचरलाई चाहिँ के भ्यापराइजेसन के अरे त्यहाँ जति टेम्परेचरमा भ्यापराइजेसन हुन्छ त्यसलाई चाहिँ के भन्छ भन्दाखेरि सेचुरेसन टेम्परेचर र सेचुरेसन प्रेसर। सब कुल्ड यो चाहिँ सेचुरेसन कर्भ भयो। सेचुरेसन कर्भ भयो। थ्री फोरमा दिएको 0.01 अनि बारबाट सुपर कुल सेचुरेटेड सब कुल स्टेटबाट सेचुरेसन लाइन हुँदै सेचुरेसन लाइनबाट भित्र गएर प्रेसर 0.01 बार भएर अनि फेरि त्यता उता निस्क्यो भने चाहिँ के हुन्छ भन्दाखेरि सेचुरेटेड भ्यापर भएर निस्किन्छ। अनि फेरि त्यसमा बाह्र त्यो उसमा हुन्छ नि, त्यसपछि त्यो क्रिटिकल पोइन्ट त्यहाँ क्रिटिकल प्रेसर 225 बार प्रेसर 225 बारभन्दा बारसम्म हुँदाखेरि क्रिटिकल पोइन्ट त्यो सेचुरेसनलाई अनि त्योभन्दा माथि प्रेसर भयो भने चाहिँ सिधै सेचुरेटेड के अरे सब कुल लिक्विडबाट सिधै सेचुरेटेड भ्यापर भएर निस्किन्छ। For a pure substance, definite relationship exists between the saturation pressure. For a pure substance, definite relationship exists between the saturation pressure and saturation temperature as shown in figure 3. Saturation pressure and saturation temperature. Vapor pressure जति भोल्युम बढ्दै and the saturation vapor is obtained is shown in figure 3. The curve shows obtain is vapor pressure curve. If the temperature of the liquid water on cooling. If the temperature of the liquid water on cooling become lower than the saturation temperature for the given pressure. The liquid water is called soft cool liquid. If the temperature of the liquid water on cooling become lower. If the temperature of the liquid water if the temperature of the liquid water on cooling become lower. If the temperature of the liquid water on cooling become lower. Cooling become lower than the saturation temperature. Then the given pressure. For the given pressure. If the temperature of the liquid water on cooling become lower than the saturation temperature. If the temperature of liquid water on cooling become lower. The temperature of liquid water on cooling. If the temperature of the liquid water on cooling become lower than the saturation temperature for the given pressure. The liquid water is called soft cool liquid. Mm, 1515912 and the super cool white. If the temperature of the liquid water on cooling is the temperature of the liquid water if the temperature of the liquid water. If the temperature of the liquid water on cooling become lower. If the temperature of the liquid water on cooling become lower than the saturation temperature. If the liquid water on cooling become if the liquid water on cooling become lower than the saturation temperature. The temperature of the liquid water on cooling. If the temperature of the liquid water on cooling become lower than the saturation temperature for the given pressure. The liquid water is called soft cool liquid. And when the pressure on the liquid water is greater than saturation pressure at the given temperature. The liquid water is known as compressed liquid. When all the liquid has been evaporated completely and heat is further rated. The temperature of vapor increase. When the temperature increase above the saturation temperature. The vapor is known as supersaturated vapor. Supersaturated vapor. Example point and point 4, 8, 11, and 11 and 13 in figure. Temperature at the same condition is known as superheated temperature. Superheated temperature. The difference between the different superheated temperature and the superheated temperature and the saturated temperature. Superheated temperature and the saturated temperature at a given pressure are is called the degree of superheat. It's called the degree of superheat. It's called the degree of superheat. As the pressure increases, the length of constant temperature vaporization get reduced. For a pure substance, definite relationship exists between the for a pure substance, definite relationship exists between the saturation pressure, and saturation temperature. For a pure substance, definite relationship exists between the saturation pressure and saturation temperature. For a pure substance glycine, definite relationship between the saturation and exists between saturation. Pure substance glycine definition relationship definite relationship exists between the saturation pressure and saturation temperature. Saturation pressure and saturation temperature is shown in figure. The curve so often in and vapor pressure curve. And if the temperature of the liquid water on cooling. If the temperature of the liquid water on cooling become lower than the saturated temperature. And if the temperature of the liquid water, if the temperature of the liquid water on cooling, if the temperature of the the temperature liquid water on cooling become lower than the saturated temperature. Mm, become lower than the saturation temperature भन्दा चाहिँ तल भयो कुलिङको कन्डिसनमा लिक्विड वाटरको टेम्परेचर चाहिँ सेचुरेटेड टेम्परेचरको लोअर भयो सेचुरेटेड टेम्परेचर सेचुरेटेड टेम्परेचरभन्दा तल भयो भने चाहिँ प्रेसर एन्ड सबको लिक्विड त्यसलाई चाहिँ सबको लिक्विड भन्छ यदि चाहिँ प्रेसर अन द लिक्विड यदि प्रेसर अन द लिक्विड वाटर इज ग्रेटर देन द सेचुरेसन प्रेसर यदि चाहिँ प्रेसर अन द लिक्विड वाटर इज ग्रेटर देन द सेचुरेसन प्रेसर एट a given temperature the liquid at a given temperature the liquid water is known as compressed liquid. When all the liquid has evaporated completely यदि सबै लिक्विड चाहिँ इभ्यापोरेट कम्प्लिटली इभ्यापोरेट भयो अनि हिट चाहिँ अझै दिइराख्यो भने भ्यापर इन्क्रिजेस दिइराख्यो भने चाहिँ भ्यापरको टेम्परेचर चाहिँ इन्क्रिज हुँदै जान्छ. When the temperature increase above the saturation temperature. When the temperature If the temperature of the liquid water, if the temperature of the liquid water on cooling become, if the temperature of the liquid water on cooling become lower than the saturation. If the temperature of the liquid water become lower than the saturation temperature, saturation temperature for the given pressure for the given liquid is subco liquid. If the temperature of the liquid, if the temperature of the liquid, if the temperature of the if the temperature of the liquid water on cooling become lower than the saturation temperature for the given pressure, the liquid water is soft to liquid. When the pressure of the liquid water, when the pressure of the liquid water, liquid water is when the pressure on the liquid water is greater than the saturation pressure. When the pressure on the liquid water is greater than the saturation pressure at a given temperature, the liquid water is known as compressed liquid. When the pressure on the liquid water is greater than the saturation pressure at a given temperature, the liquid water is known as compressed liquid. When all the liquid has been evaporated completely, when all the liquid has been evaporated completely and heat is further added, the temperature of vapor increases. When all the liquid has been evaporated completely, when all the liquid has been evaporated completely and heat is further added, the temperature of vapor increases. When the temperature increases over the saturation temperature, the vapor is known as superheated vapor. The difference between the superheated temperature and the saturated temperature at the given pressure is called degree of superheat. The difference between the superheated temperature and the saturated temperature at a given pressure is called the degree of superheat.
As the pressure increases, the length of the constant temperature vaporization get reduced. As the pressure जति pressure बढ्दै जान्छ, length of constant temperature vaporization, length of constant temperature vaporization get reduced हुँदै जान्छ. अनि critical point भनेको the state of substance at which liquid and saturated vapor have identical properties is called critical point. The state of substance at which saturated vapor have identical properties is called critical point. Saturated त्यसको चाहिँ फरक property हुन्छ, त्यसलाई चाहिँ critical point भन्छ. This much for today, guys. Bye bye. अब नाच्न खानु पर्यो.